Today we are going to do the analysis of a beam which has a span of 10 meter. It has a point load of 10 kilonewton at a distance of 1.5 meter from left corner, and similarly there is a UVL, UDL, and again a UVL, and there is a movement in clockwise direction and another movement in anti-clockwise direction. Just keep in mind the values of these various loads and movements. If possible, take the screenshot for the reference. Then we will go to for the analysis. So we will run the ANSYS APDL mechanical APDL. We select preprocessor, structural, preferences as structural. Then we'll go to preprocessor, add element type, add or delete beam. Then we'll go to material properties, material models. Always keep in mind why we have to always define the value of Young's modulus, otherwise there will be no, and this is done by the software. Assume any value, but generally always assume the value as 200 e raised to 3. Then go to sections, beam, common section, select the section as square, or we can select any type of section from here, subtype. So we will select square, and we will give its breadth as 40 and width the height as 40. Then click on OK. After we'll go to modeling, create key points, negative CS, apply 1500, that is 1.5 meter, then 2000, that is 2 meter, then 8000 that is 8 meter, and 10,000 that is 10 meter. Then we will go for applying for creating lines, straight line, click on OK. Then we will go to meshing, size control, manual size, lines, all lines, 10, OK. And then we will go to mesh, lines, we will directly click on pick all. So the meshing is done. Then we will apply the loads and boundary condition. So first we will apply the fixed support and roller support. So we will go to displacement, on key points, select the key point at left corner and do all DIF as 0. After that we will select the right corner key point and select UI, UX, UV, UZ, ROT-X, ROT-Y, ROT-Z means ROT-X, ROT-Y, ROT-Z means rotation at X, rotation at Y, rotation at Z. Only unselect the UX and all DF because there is no constraint in X direction for roller support. Then click on OK. After that we'll apply the point loads and moments. First, to see the lines clearly, we will go to multiplot. Then we'll apply the load, that is of minus 10 kilonewton because it is in negative direction, in X direction, so minus 10 kilonewton. After that we'll apply the movement on key point, that is first key point at 2 meter distance, where the rotation is in Z direction because rotation is in Z axis. So and the value and it is in anti-clockwise direction, so negative value, and kilonewton meter is converted into Newton mm, so we will apply we will multiply 5 with e raised to 6 and apply, and here one movement is also applied, and as it is in clockwise direction, so 10 e raised to 6. After that we will apply UVLs. So we will go for in pressure on beams, and we will carefully select the nodes. So first we will select the corner nodes. select the corners carefully. So to select it, we will go to zoom model and select the area where we want to zoom. Then we will select the key point, select the nodes. Here is one, select the elements or nodes. So we had selected the elements. So all 2 meter span is selected. Then click on OK. Always keep the logical value as 2, starting value 0 and ending value as 6, because 6 kilonewton per meter is converted into 6 newton per mm. So there will be no power to it, only 6. Sorry, the value is 3 kilonewton per meter, so it will be 3. Click on apply. Then here it is a UDL, fake, and the value is 4 kilonewton per meter. On OK. Then again there is a UVL, see that the elements are selected correctly. Click on OK, and here the span is from 6 kilonewton to 0. So starting point will be 6, then ending point is 0. So we can see a decreasing order. Here it is increasing order, and here it is constant. After that we will go to solution, solve, current ls. Okay, solution is done. After that we will see the deformation, and to see the deformation clearly, first we have to make it in 3D shape. So go to plot controls, style, size and shape, and select tick it. Okay, so as you can see it is in 3D format. The span is bigger, so we cannot see the cross section carefully. If we zoom it, we can see it. So I will make it just visible care nicely. So now we can see there is a beam of square cross section. After that we will see the deformation shape in deform shape, deform plus undeformed. So we can see there is, so here we can see there is, this is the actual beam, and after applying load there is this much deformation. To capture this picture, go to plot controls, hard copy to file, select JPEG, reverse video to make the background white, landscape. Okay, the directory will be this file will be saved where we have set the directory of our ANSYS file previously while running the launcher. So always keep in mind. Then we have to see the maximum displacement. So go to nodal solution, DF, replace the vector sum, click on OK. So we can see the maximum displacement. Again capture this image also, similar settings, click on OK. After that we have to see the SFD and BMD. So for SFD and BMD, go to element table, define element table, and define the values by sequence number. SMISC 3, apply. By sequence number SMISC 6, apply. By sequence number SMISC 16, apply. By sequence number SMISC 19, and click on OK. After that we will go to this result, element table data, sorry, not element table data, plot result, elements, sorry, we will go to plot result, element table. So plot result, line element result, and select here 3, and 16 is not defined, so we will again go define the 16 value. 16. Again go to clause result, line element result, and SMISC 3 and SMISC 16. This is for this is for BMD. SMIS 3 and SMIS 16 is for BMD. So here we get the BMD. So capture this image, go to plot controls, hard copy, file, click on OK. After that we will have to see the SFD. So again go to line element result, select 6, 9, SMIS 19 and click on OK. So this is SFD. Again capture this picture by clicking on hard copy to file, OK. Thus the analysis of beam is completed. Thank you.